question number. We will solve those MCQs as well. So with that, we will now begin the chapter electric potential and capacitance. We'll discuss some of the important concepts on electric potential. Capacitance, then on videos upload ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. Go through the capacitance video. It's only about 1 or 2 classes of the capacitance. ಕೆಲವೊಂದಷ್ಟು ಟಾಪಿಕ್ಸ್ ತೆಗೆದಾಗ capacitance ಇಂದ. So 1 or 2 classes will be sufficient for capacitance. Go through that and we will even solve some of the MCQs from capacitance as well. See, I have told you what is meant by electric potential. Electric potential will be defined at some point in the electric field. Electric potential will define ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ electric potential is to be defined at some point in the electric field. You know that a source charge is capable of producing electric field around. Let us suppose there is some point A in this electric field. At this point A, you can define electric potential. Electric potential must be defined at a point in the electric field. See, point B is a point outside the electric field where you cannot define electric potential. All electric potential define ಮಾಡಲಿಕ್ಕೆ ಬರಲ್ಲ. Electric potential must be defined at a point in the electric field. How is electric potential defined ಅಂತಂದ್ರೆ electric potential at a point in the electric field is defined as the amount of work done in moving a unit positive test charge from infinity to given point in the electric field. Infinity, the point A ಗೆ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ನೀವು ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತದೋ ಆ ವರ್ಕ್ ನೇ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. Electric potential at a point in the electric field is defined as the amount of work done in moving a unit positive test charge from infinity to given point in the electric field. The question arises as to why work is to be done. ಯಾಕೆ ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತದೆ ಅಥವಾ against what we have to do work. Now if I have to raise this object, suppose this is an object lying on the surface of the earth. Suppose I want to raise this or lift this object to certain height, I'll have to do work. Against what force I have to do work? ಯಾವ force ಗೆ against work ಮಾಡಬೇಕಾಗ್ತದೆ? In order to lift this object to certain height, I'll have to do work against some force, which is that force against which I have to do work. ಯಾವ force ಗೆ against work ಮಾಡಬೇಕಾಗ್ತದೆ ಹೇಳ್ತೀರಾ? ಈ object ನ certain gravitational force, very good. We have to do work against gravitational force in lifting this object. If I try to lift this object, gravitational force tries to pull the object in downward direction. So against that gravitational force, I'll have to do work. Similarly, when I start moving this test charge from infinity to some point A in the electric field, this source charge or electric field produced by this source charge exerts electric force of repulsion on this test charge. The electric field produced by this source charge repels the motion of this test charge or opposes the motion of this test charge. It is positive other, the test charge is positive other, however the source charge will repel this test charge. Now we are trying to bring the test charge towards the source charge. Test charge the source charge hatra tagಲಿಕ್ಕೆ try ಮಾಡ್ತೀವಿ, but source charge will repel the test charge. Source charge opposes the motion of the test charge. However, in order to move this test charge from infinity to some point in the electric field against the electric field produced by the source charge, you will have to do work. That work done in moving a unit positive test charge from infinity to some point in the electric field is called as electric potential at that point. E point electric potential ಎಷ್ಟು ಅಂತಂದ್ರೆ work done in bringing unit positive test charge from infinity to given point in the electric. Electric potential is represented by V and is defined as W divided by Q naught, where W is the amount of work done in moving charge Q naught from infinity to point. This is the formula for electric potential. Can you tell me, will potential be same at each and every point in the electric field? Say we have some 3 points A, B and C. Do you think electric potential will be the same at all 3 points A, B and C? Andre, will I have to do same amount of work to move the test charge from infinity to C? infinity to B and infinity to A. Will I have to do same amount of work to move the test charge from infinity to C, infinity to B and infinity to A? Do you think electric potentials be the same at each and every point in the electric field? E point potential same the answer is no. At each and every point in the electric field produced by a single source charge, potential will be different. You will have to do very large amount of work to move the test charge from infinity to A because point A is very close to source charge. Point A to source charge is bada hatra irodrinda, if you have to move the test charge from infinity to point A, you will have to do more amount of work. ಯಾಕಂದ್ರೆ ಚಾರ್ಜ್ ಹತ್ರ ಬಂದಂಗೆಲ್ಲ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಹತ್ರ ಬಂದಂಗೆಲ್ಲ ಅದರ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಹಾಗಾದ್ರೆ we will have to do more amount of work to bring the test charge from infinity to point A. A little less amount of work to move the test charge from infinity to point B. Least amount of work to move the test charge from infinity to point C. Andre potential at point A, potential at point B and potential at point C will be different. If I write potential at point A as VA, potential at B as VB and potential at C as VC, VA will be greater than VB, will be greater than VC. VA will be greater than VB and that will be greater than VC. This will be the relationship, right? So potential at a point in the electric field depends upon distance of that point from the source charge. ಯಾವ point source charge ಗೆ ಹತ್ರ ಇರ್ತದೋ ಆ point ಹತ್ರ potential ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಇರ್ತದೆ. The point which is close to the source charge, suppose this is source charge and if this is a point, the point if very close to the source charge, potential at that point will be greater. ಯಾವ point source charge ಇಂದ ಬಹಳ ದೂರದಾಗ ಇರ್ತದೋ ಆ point ಹತ್ರ electric potential ಬಹಳ ಕಮ್ಮಿ ಇರ್ತದೆ. So electric potential at a point depends upon distance of the point from the source charge. More is the distance of the point from the source charge, less is the electric potential. Less is the distance of the point from the source charge, ಇದು source charge, ಇದು point. Less is the distance of the point from the source charge, more will be the electric potential. ಯಾವ point source charge ಗೆ ಹತ್ರ ಇರ್ತದೋ ಆ point ಹತ್ರ electric potential ಜಾಸ್ತಿ ಇರ್ತದೆ. ಯಾವ ಪಾಯಿಂಟ್ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಂದ ಬಹಳ ದೂರ ಇರ್ತದೋ ಆ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕಡಿಮೆ ಇರ್ತದೆ, ರೈಟ್? ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ಯೂ ಟು ಎ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ಪಾಯಿಂಟ್ ಫ್ರಮ್ ದ ಸೋರ್ಸ್ ಚಾರ್ಜ್. ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಂದ ಆ ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಾಗದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಆ ಪಾಯಿಂಟ್ ಹತ್ರ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಐಡಿಯಾ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್. ಹಾಗಾದ್ರೆ ದ ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ ಫಾರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಈಸ್ electric potential is given by work done by unit work done in moving unit positive test charge from infinity to Q1 point. This is the basic formula for calculating electric potential. Also, electric potential due to a point charge is given by 1 by 4 pi epsilon naught Q divided by R. I have told you, if this is a source charge, this source charge will produce electric field around it. I can define electric potential at some point A in the electric field. See, A is a point in the electric field. In order to test charge from infinity to point A, I will have to do work. The amount of work done in moving unit positive test charge from infinity to point A is called electric potential at point A. E point hatra electric potential ಎಷ್ಟಿರ್ತದೆ ಅಂತಂದ್ರೆ W by Q naught ಅಂತಾನೂ ಬರೀಬಹುದು. Or in terms of distance of the point from the source charge, in terms of distance of the point from the source charge, potential at this point can be written as V is equal to 1 by 4 pi epsilon naught Q divided by R. V is equal to 1 by 4 pi epsilon naught Q divided by R. From this you can notice that electric potential is inversely proportional to the distance of the point from the source charge. Electric potential at a point is inversely proportional to the distance of the point from the source charge. Source charge in the point A ಅಥವಾ point P ಎಷ್ಟು ದೂರದಾಗದೆ ಅನ್ನೋದ್ರ potential depend ಆಗಿರುತ್ತೆ. How does it depend on it? Depends inversely proportional to the distance. More is the distance of the point from the source charge, less is the potential, right? And you can also notice that electric potential at a point is directly proportional to the magnitude of the source charge. More is the magnitude of the source charge, more is the potential at a given point. Electric potential is directly proportional to magnitude of the source charge and is inversely proportional to the distance of the point from the source charge. Right? This is the idea of electric potential. Now, we can also define the concept of potential difference. Potential difference. We know what is potential difference. Suppose this is a source charge. We know that this source charge will produce electric field around it. I'll choose some 2 points A and B in the electric field. I'll choose 2 points A and B in the electric field. Let us suppose a unit positive test charge Q0 is placed at point A. The amount of work done, okay, tell me, will we have to do work to move the charge from A to B? Will we have to do work in order to move the test charge from A to B? This is positive source charge, this is positive test charge. Will we have to do work to move the test charge from A to B? In the B ಗೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕು ಅಂತ ವರ್ಕ್ ಮಾಡಬೇಕಾ ಇಲ್ಲ ಆಲೋಚನೆ ಮಾಡಿ ಹೇಳಿ. ಇದು ಪಾಸಿಟಿವ್ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇದೆ, ಇದು ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇದೆ. ಎ ಇಂದ ಬಿ ನಾನು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕು, ಹಾಗಾದ್ರೆ ಎ ಇಂದ ಬಿ ಗೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ವರ್ಕ್ ಮಾಡಬೇಕಾ ಇಲ್ಲ? Will I have to do work or not? Yes, we have to do work against the repulsive force exerted by the source charge or the test charge. If I try to move the test charge from A to B, the source charge exerts force of repulsion on the test charge and opposes its motion. So in order to move the test charge from A to B, we will have to do work. See, the amount of work done in moving a test charge from one point to another point in the electric field. Amount of work done to move the test charge from one point to another point in the electric field is called as potential difference. It is called as potential difference between these 2 points. Potential difference between these 2 points is defined as amount of work done to move the test charge from one point to another point in the electric field. Potential difference is generally represented by dV. Potential difference is represented by dV and is defined as dW divided by Q0. See, because the points are very close to each other, a small amount of work has to be done to move the test charge from A to B. dW is the amount of work done to move the test charge Q0 from A to B in the electric field. Right? This is how potential difference is defined. This is how potential difference is defined. Suppose you know the potential difference between these 2 points. Suppose you know the potential difference between these 2 points. ಈ ಎರಡು ಪಾಯಿಂಟ್ ಮಧ್ಯೆ potential difference ಒಂದು ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Suppose point B is at potential 10 volts and point A is at potential 5 volts. Notice the point which is close to source charge will have higher potential 10 volts. The point which is at larger distance from the source charge ಇಂದ point ಗೆ ಬಹಳ ದೂರ ಇದೆ. So ಈ point ಗೆ potential ಕಮ್ಮಿ ಇರುತ್ತೆ because potential is inversely proportional to distance. More is the distance of the point from the source charge, less is the potential. Okay. We now know the distance, potential difference between 2 points. This point is at 10 volt and this point is at 5 volt potential. So we know what is the potential difference. Potential difference between these two is 5 volts. dV. Potential difference between these two is 5 volts. Test charge to be moved from A to B is Q0. Q0 charge move ಮಾಡಬೇಕು. Potential difference ಹೋಗ್ತು, charge ಕೂಡ ಹೋಗ್ತು. Can we calculate what amount of work has to be done to move the charge from A to B? Can we calculate the work done in moving the charge from one point to another point? Yes, that can be done. Work done to move the charge from one point to another point, dW, is equal to dV into Q0. Work done to move a charge from one point to another point in the electric field is dV into Q0. Work done is equal to potential difference into charge. Work done is equal to potential difference into charge. Remember this relationship. Electric field ನಾಗೆ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಗೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ dW is equal to dV into Q0. ಯಾವ ಪಾಯಿಂಟ್ ಇಂದ ಯಾವ ಪಾಯಿಂಟ್ ಗೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡ್ತಿದೆ ನೋಡಿ, A ಇಂದ B ಗೆ. ಓಕೆ, what is the potential of A? 5 volt. What is the potential of B? 10 volt. Calculate the potential difference between them. 10 minus 5. 5 volt is the potential difference. See what amount of charge is to be moved. Suppose you have to move 1 nanocoulomb charge. 5 volt into 1 nano coulomb. 5 nanojoules of work has to be done. 5 volt into 1 nano coulomb. 5 into 1 is 5. Nano volt into coulomb. Volt into coulomb. Volt into coulomb. Volt into coulomb. Potential is measured in volts. Charge is measured in coulomb. Volt into coulomb gives us work done. Work done is to be measured in joule. So, however, volt into coulomb should be written as joule. So, 5 nanojoules of work is done. 5 nanojoule of work is done to move the test charge of 1 nanocoulomb from point A to point B. This is how work done is to be calculated. Work done to move a test charge from one point to another point in the electric field is given by potential difference into charge. Potential difference into charge. So remember the definition of potential difference. Potential difference is defined as the amount of work done to move a unit positive test charge from one point to another point in the electric field. From one point to another point in the electric field, right? Electric potential is different. Electric potential is amount of work done to move the test charge from infinity to given point in the electric field. Infinity in the given point in the electric field is electric potential. From one point to another point in the electric field, electric potential difference, right? Electric potential difference is represented by dV. It's given by dW divided by Q naught. dW represents work done and Q naught represents test charge, right? This is regarding electric potential and electric potential difference. This is electric potential in terms of work done and charge. This is electric potential in terms of distance of the point from the source charge. Question note 20, you have to choose the right formula. And this is the formula for potential difference. After this, you must know what is the nature or what is the SI unit of electric potential. Electric potential SI unit ಏನಂತೆ ಅದು ಗೊತ್ತಿರಬೇಕು. You must know the dimensional formula for electric potential and you must know the nature of electric potential, whether electric potential is scalar or vector. See, the SI unit of electric potential is joule per coulomb. Electric potential is defined as work done by charge. Work done by charge, work done is measured in joule and the charge is measured in coulomb. So the SI unit of electric potential is joule per coulomb, right? Dimensional formula is to be written. Dimensional formula for electric potential. You know that electric potential is V is equals to W divided by Q1. Work done calculated as force into displacement divided by. I have told you how to express charge. Charge is to be expressed as current into time. Charge is to be expressed as current into time. See, dimensional formula ಬರಿಬೇಕಾದ್ರೆ given physical quantity should be expressed in terms of fundamental physical quantities. Current is a fundamental physical quantity and time is a fundamental physical quantity. Charge is equals to current into time. Current into time. Force can be expressed as mass into acceleration into distance. Force is mass into acceleration. S is distance or displacement divided by I into T. We know that mass is measured in kg. Mass is measured in kg. Acceleration is measured in meter per second square. Displacement is measured in meter. Current is measured in ampere. Time is measured in seconds. So if I have to write the dimensional formula for electric potential, the fundamental quantities that are involved are kg is the unit of mass. Mass is meter into meter square. So kg power 1 meter into meter is meter square. Meter is unit of length. So L square. S now this is S power 1. S power 1 when goes to correct become S power minus 1. The minus 2 there. Minus 1. Minus 2 minus 1 is minus 3. So time power minus 3. Current by involved potential also depends on current. So ampere current is measured in ampere. Ampere now over ampere power minus 1. So this is the dimensional formula for electric potential. M1 L2 T minus 3 A minus 1. This is the dimensional formula for electric potential, right? So SI unit of electric potential is Joule per coulomb. Dimensional formula for electric potential is M1, L2, T minus K and A minus 1, right? And electric potential is a scalar quantity. Electric potential is a scalar quantity. Electric potential is a scalar quantity. That means it obeys ordinary laws of algebra. No special vector laws are to be made use to evaluate scalars. Scalars obey ordinary laws of algebra. At a point, potential due to many charges can be just added like real numbers. First charge in the point P at the potential 10 volt. Second charge in the point P at the potential 5 volt. Third charge in the point P at the potential 5 volt. What is the net potential at point P? Net potential at a point due to many charges is the algebraic sum of potentials due to individual charges. First charge is potential produced 1 to 10 volt. Second charge 5 volt. Third charge 5 volt. Algebraic sum of potential due to individual charges is 10 plus 5 plus 5, 20 volt. So potentials can be added just like real numbers. Potential being scalar quantity obeys ordinary laws of algebra, right? So this is regarding the basic idea of electric potential. So go through the basic ideas of potential once again. Have even sent you the notes. ಇನ್ನೊಂದ್ಸರಿ ನೋಟ್ಸ್ ಕಳಿಸ್ತೀನಿ ಇದ್ರದ್ದು ಕೂಡ ಸಿನಾಪ್ಸಿಸ್ ಕಳಿಸ್ತೀನಿ electric potential synopsis ಇನ್ನೊಂದ್ಸರಿ ಕಳಿಸ್ತೀನಿ ನಾನು. Go through the basic ideas of electric potential and I will be very soon uploading the videos on capacitance also. ಎರಡು ಅಥವಾ ಮೂರು ವಿಡಿಯೋ ಇರ್ತಾವೆ ಅಷ್ಟೇ capacitance small topic. Try to finish that topic as well. We'll take up the synopsis of capacitance as well. We'll first finish off the synopsis of electric potential. We'll solve the MCQs on electric potential and then we'll take up the synopsis of capacitance. Right? Idaad takshana immediately I will be uploading the videos on current electricity also. Capacitance aad takshana immediately we'll start videos on current electricity also. Try to go through the videos. If sadhya classes start agodantu doubt ade, so try to be as regular as possible. Even doubt idre phone ಮಾಡಿ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಮುಂದೆ ಬಹಳ ಕಷ್ಟ ಆಗ್ತದೆ. ಯಾವಾಗ ಕಾಲೇಜ್ ಓಪನ್ ಆಗ್ತದೆ ಗೊತ್ತಿಲ್ಲ. So try to be as active as possible, right? We will end this class now and we'll continue in the tomorrow's class again, right? We'll continue tomorrow, please.